things where we talked about one gas at a time. But very rarely do you have one gas at a time. That was actually the problem with the lab. One of the problems. You collected it over water. Water evaporates. So you didn't have just butane in your flask. You also had water vapor in there, and you had more than one kind of gas. So Dalton's law of partial pressure deals with the situation where you have more than one kind of gas. What do? Dalton figured out that what you do is you ignore the other gases. You can treat each gas as if it's by itself. And then if you want the total pressure, just add up the pressures of all the individual gases. So that when they say the partial pressure, there's the air in this room is made up of oxygen and nitrogen, right? So we're being hit by oxygen molecules and we're being hit by nitrogen molecules. The partial pressure of oxygen is the oxygen hitting us. The partial pressure of nitrogen is the nitrogen hitting us. The total pressure is the pressure of the nitrogen plus the pressure of the hydrogen, the pressure of everything hitting us. So if you think of pressure as collisions, this makes sense. The pressure caused by oxygen is the pressure caused by oxygen molecules. As a mathematical expression, this one's going to be different than the other ones. It looks like this. P total equals P1 plus P2 plus P3 plus, keep going and going. The total pressure is the pressure of the first gas plus the pressure of the second gas plus the pressure of the third gas. When do I stop adding pressures? When I run out of different kinds of gases. That make sense? Okay. Por ejemplo, you look at these four containers. These four containers. First one's got the green atoms. Second one's got the orange atoms. Third one's got the blue molecules. The fourth one's got the green atoms, the orange atoms, and the blue molecules. It's got all of them. So the pressure in that fourth one should be the same as the three added up. So if the first one's 2 atmospheres, the second one's 1 atmosphere, and the third one's 3 atmospheres, what's the pressure in the fourth container? 6 atmospheres. 2 plus 1 plus 3. Extra super hard. That's it. It's really easy to do. The problem is it's so easy, people forget it. That you can treat each gas individually, as if the other gas isn't there. And it makes sense. If the gas molecules don't take up any size, we can pretend they're not there. Does that make sense? If they don't take up any space, we can pretend they're not there. So that's the whole idea. So we can treat gases in the same container as if they don't affect each other. You just figure out their pressure separately. And add them to get to the total. That was one of the ways, we've already actually addressed this a little bit, that number 9 on the homework you turned in, Gas Law Practice 3. That you had moles of nitrogen and moles of oxygen. I just added the moles together because it didn't matter what kind of moles they were. But I could have figured out the pressure of the nitrogen and the pressure of the oxygen and added those together. If you did that, you followed Dalton's law of partial pressures. Ta-da! That's all there is to it. Oh, it's really, actually, it has lots of impacts, but that's all there is to this. Gee, what do you see here? So, what is the total pressure in a balloon filled with air if the pressure of the oxygen is 170 millimeters of mercury and the pressure of nitrogen is 620 millimeters of mercury. It's number 7, I think. It's on the list. We skipped it earlier. 8. Should be up early. Oh, it's number 9? Number 9? Number 9? Okay. So, hey, I've got a pressure of one gas and I've got a pressure of a second gas. I've got 2 pressures. I actually am going to say, ooh, this one's for nitrogen and this one's for oxygen. Well, I got it backwards, didn't I? Okay. Anybody think of an equation we could use to solve this? Extra super hard? Let's see. So that pressure of O2 was 170 millimeters of mercury. The pressure of N2 was 620 millimeters of mercury. So that means the total pressure is going to be 790 millimeters of mercury. Ta-da! Extra super hard. Okay, then let me give you the hard version. This is the hard version. In a second balloon, the total pressure is 1.3 atmospheres. What's the pressure of oxygen if the pressure of nitrogen is 720 millimeters of mercury? This would be number 10. So what they tell me? They told me total pressure. And they told me pressure of nitrogen. They asked me for pressure of oxygen. Anybody think of an equation? Well, P total equals P nitrogen minus plus P of oxygen. I'm trying to solve for P of the pressure of oxygen. So that means I need to subtract pressure of nitrogen from both sides. So that the pressure of oxygen equals the total pressure minus the pressure of the nitrogen. So I stick in those numbers. 1.3 atmospheres minus 720 gets me negative 118. Negative 718, is that right? No, it's not right. Negative pressure, less than 0 hitting. That doesn't make sense, does it? Units, atmospheres, millimeters of mercury. You can't subtract those two. Okay, so I got to change one. I'm going to change the atmospheres. 1 atmosphere is 760 millimeters of mercury. So 1.3 times 760. Uh, 990, 2 sig figs in the 1.3. So if I write that as 990 millimeters of mercury minus 720, that is 270 millimeters of mercury. See how tricky that was? We solved for the other one, so we solved for a specific one, so we had to subtract. The units didn't match up, so we had to fix that. That's as nasty as they could get. And the place it actually shows up is in your lab. The reason why your lab wasn't going to work was because you didn't have just butane in the flask. You bubbled butane, so the only gas that came in was butane. But then you had water there. That water is going to evaporate. So the pressure inside your flask is too high. Okay. Some simple homework. I will see you on Wednesday.
Does the bell sound different, or am I going crazy?
Those two are not mutually exclusive.
Okay, well, am I going crazy because the bells sound different?
They're off a little bit. I don't know why.
Can I stay and do a mini quiz real quick?
Yep. We should be able to. If your sixth period teacher doesn't care. Have a good one.
Yeah, I'm 1,000% going crazy right now, but that's for completely separate.
Say, sometimes your or choices are not ors. Maybe you should use and or. You do. Oh, thank you. Okay, the notes are online. We walked on the end of them.
All right.
Okay, and you'll have to make up the quiz. So if you want to, you can do it. We have fourth all week next week. So if you want to stop by and get a pass, because I won't see you till Wednesday. If you want to take it ahead of time.
All right.
Okay. Have a good weekend.
It's supposed to be the last one, right?